Okay, so like I was saying, 25 mod 2 is, it's 1 because 25 divided by 2 is 12, and then 12.5, but the 0.5 gives me the remainder 1. And then 24 mod 2 is 0 because the 24 is evenly divisible by 2. So sometimes we wanted to tell even and odd numbers apart, and the mod 2 operation gives us that. Those are kind of the two things that you need to remember about mod, but they occur often enough that you will see it several times in class. Powers and roots are not kind of easy. You just have to know that you can't just write x to the n. You have to call this function called math.pow, and you give it x and n. The only exception is it's tedious if you want to square something, which happens all the time. I don't write math.pow of x comma 2 because it's so much faster to just write x times x, and there's no shame in doing it. It actually executes faster too. Square roots, there's a function called math.square root that computes the square root in the normal way. If and when you need it, it's easy enough to use. There's a few other mathematical functions that we might actually run into. In fact, in one of the homework assignments, we're going to be using mathmin and mathmax that compute the minimum and maximum, and they're easy enough to understand. Mathmin of 31 and 17, for example, what is it? Yeah, this is not rocket science. This is not even a trick question. No, that's a good one. It's 17, right? It's the smaller of the two. Yeah. So there'll be a homework assignment where you're going to have to compute the minimum of a whole bunch of numbers. And the way it works is you first compute the minimum of the first two, then of whatever one was the smaller and the next, whatever one was the smaller and the next, and so on. And that way you'll find the minimum of all of them. I'm not.
You can do 2 at a time.
What's that?
You can do 2 at a time.
You can only do 2 at a time, unfortunately, yes. It would be nice if you could say math min and then have as many as you would want. Would make sense too, but that's not how math minimum works. For really no great reason. It could work like that. All right, the other nasty thing is casting and rounding. And we'll just have to get to it. It's a little unintuitive. When you have a floating point number, over here, the balance here, notice it's a floating point number. It's a floating point number. It's okay as a double. And if you want to convert the floating point number into an integer, for whatever reason, you just want to lose the fractional part and you just want to cram it into an integer, the notation for that is somewhat bizarre. You have to you put int in parentheses and put it before the number. And that notation is called a cast. You're turning this thing into an integer. So, for example, int of 31.58 is 31. You just lose the fractional part. The operation itself is, I think, is okay. It's just that the way you write it, it's weird. It's not a function call. And you just have to live with it that it's a special notation. Now, sometimes you want this kind of casting. If you want to lose, say, all pennies, then that makes sense. But oftentimes, it's actually not what you want. What's more commonly used in mathematics is rounding. And if you want to round this thing up, you would want to round it up to 32, right? Because that's the closest integer. Because casting is kind of brutal. Even if it's 31.9999999, you're going to lose all of those 9s, and it's going to give you 31. But if you want to have the nearest one, you have to use round of balance, or whatever, round with the amount. So the math round function, in this case, if you'd call that then that's 32, which makes sense, it's rounded to the nearest integer. But, somewhat cruelly, it is 32 as a so-called long value. There's multiple integral types. There's int, kind of the normal integer type, and then there's long that uses twice as many bits. Integer goes from about -2 billion to +2 billion, which is plenty for almost all of the uses that we're going to be having in class. Like if I ask you to draw some number of stars, you're not going to be drawing more than 2 billion of them. But it is possible for a floating point number to be very large. You could have a floating point number, let's say 10 to the 100, and then it wouldn't fit into 2 billion, which is what, 10 to the 12 or something. And so in that case, you would get it as a long value, which is more likely to hold those. So if you really wanted this as an integer, if you wanted this as an int, you then have to also add a cast here that truncates the long to it. This happens very rarely, actually, but it does occasionally happen. In this case, you have to remember that to take the floating point number and make it into the nearest integer, you have to both call math round and you have to apply the cast in just this order. I would look it up at that point. All right. So these self-checks, and then we'll go break for lunch. What's the value of n after these two statements? Yeah, n minus 1, right? 1 less than it was before. What's the value of 1729 divided by 100? It's 17. It's not 17 point anything because they're both integers. And what's 1729 mod 100? Yeah. So the slash and the mod let you take, if you divide by 10 or a power of 10, then you can take numbers apart into the digits. That's the actual value. All right, that's what we got. Oh, no, this is a good one. Why doesn't the following statement compute the average of S1, S2, and S3? Yeah?
Because S1, S2, and S3 are in parentheses.
That's right. So over here, we didn't have the parentheses. I was hoping that someone would fall into the trap and say, oh, because they're integers. But that might be a different error. Right? So the error that I was after is. So in this case, now it'll be correctly computed. I shouldn't say that, because what if they were integers? Maybe I just trapped it. What if these are integers? It's not going to round them. Let's take three values. Let's say 1, 2, and 2. What's the average? It can't be exactly 2, right? What's the average? 1.67, right? What is 5 slash 3? 1. It's 1. That's far away from 1.67. How do I fix it? I divide by 3.0. So there were 2 errors in here. Okay? See what the answer is. Huh? Yeah. All right, now we don't. Here we go. All right, good enough. So let's regroup at 12. If you've, for whatever reason, wanted to get started over lunch, go ahead and do it. So I will be here from 12 to 12:15, 12:20 or so. See that everyone is getting okay with the labs. And so what you have to do this afternoon is to do both, to do all of the labs. It's 4B, 4C, and 4D.
Okay. I was wondering because it says Dropbox lab 4 part B is due at noon.
Yes, I'm going to fix it. I'm going to make it so. And can you please change the scribe and the driver in those 2 portions? So you have one scribe driver for 4B, and then you switch for 4C and 4D.
Okay.
All right.
So C and D will be grouped together.
Yes, so I make two drop boxes, one for B, one for C and D, and I'll make them both due at 1:30, but if you wanted to shift your time and do it early, that's okay with me. So as long as I get them all by 1:30, I'm a happy camper.
So last night I turned in the homework.
Oh,
I got a
start now or
receipt
take a
for
break?
it, but then you didn't get it.
matter.
Okay, let's, you want to come to my office?
I'd be cool doing it now.
Yeah, yeah, then he's here too.
I don't really know anything about that. I would rather just get it done.
Alright.